Hello, grade 10s. Today we are going to be looking at percentage composition. What is percentage composition? It is a percentage of an element in a compound. We have just looked at empirical formula as well as molecular formulas, and you will see just from the calculation at the bottom or the formula at the bottom that we can work out empirical formula from the percentage composition and vice versa. It is linked to the mole ratio and therefore the coefficient um, in front of a compound within a chemical reaction. If we determine quantitatively, that's by numbers, how each element contributes to a compound, we can determine the experimental formula, therefore the empirical formula, and thereafter we can determine the molecular. So you see, this is important. Everything is linked here. Bottom of the slide, you will see that there is an actual formula there on how you can calculate this, and it's relatively simple. I don't think any of you will struggle with this at all. You're going to look at the mass of the specific component, so therefore the molar mass of the element. So I want you to write that in, the molar mass of the element, and that is going to be divided by the molecular mass or the relative molecular mass of the compound. Thereafter, you're going to times it by 100 and you should come up with the percentage composition of that particular element for the compound. To go into more detail now regarding percentage composition based on the previous slide, we're just going to break this down once again. And there's an example that I have pasted onto the slide using carbon dioxide. So once again, you find the molar mass of a compound by adding up the masses of each atom in the compound using a periodic table. Okay? You calculate the mass due to the element for which you are solving by adding up the mass of these atoms. That is important, grade 10. You need to bear in mind how many atoms. Just like before when you were working out relative molecular mass, you need to do the same for the element. You divide the mass due to the element by the total molar mass of the compound and multiply by 100. So you can see in the carbon dioxide example, literally each elemental mass is divided by the molecular mass and times by 100, and then you get a percent. And as you can see for this one, we have got 27.3 for carbon and 72.7 for your oxygen. And the sum of the percentages should equal to 100. If you get stuck and you're not sure about rounding off, you're just going to round off these percentages to the 10th. Hopefully you are all on page 16 of your stoichiometry booklets. You see it's at the bottom of the page after you've done those empirical formulas. It gives a little definition of the percentage composition, and then there's an example using sulfuric acid. And I've broken it down here for you guys. You're obviously going to write down your formula first. You're going to work out your molecular mass. And then from that, with each element involved in the compound, you are going to figure out, or you are going to calculate the percentage composition using the molecular mass and multiplying it by 100. So please write this in now at the bottom of page 16. Then you are going to pause this video and you are going to do the practice on page 17. Guys, it's super simple. It's really not that difficult whatsoever. Just please try, and you will see that the question 2 has got a weird abbreviation or notation there. It's got copper sulfate and then a little period, and it says 5 molecules of water. All this means is that there's 5 water molecules to 1 copper sulfate molecule. That's all it means. It means in that particular compound, it dissolves in water and it dissolves in 5 molecules of water for every molecule of copper sulfate. Okay, so at this stage of the game, most of you should have worked all of this out and found it relatively simple. I've written them out by hand, and then I've gone and scanned in the answers and pasted them into these slides. So just have a look at how I have written them out. For the first question, it's asking, find the percentage composition of calcium carbonate. That's why you'll see I've just abbreviated and just said PC calcium carbonate. The first thing I've done is I've looked at the molecular mass, which is equal to 100 grams per mole. And then from that, I've taken that molecular mass and I've used it for for the molar mass of each element. You'll see that for calcium, you should get 40%, carbon 12, and oxygen 48%. Question 2, as I said before, that abbreviation or notation just means that for every molecule of copper sulfate, you are going to have 5 molecules of water. So it's asking here, find the percentage of waters of crystallization in your copper sulfate within 5 molecules of water. We haven't done this yet. I'm not going to go into how this works. Okay, I just want you to see that it's asking for the water, percentage composition. It's not asking for the copper whatsoever. So what you need to do is you need to break this down now, and you need to work out the molar mass for the entire compound or the entire solution. And I've broken it down there for the copper sulfate as well as for the water, and you should have gotten 249.5 grams per mole. From that, you just take the molar mass for the water. That is it. Grade 10s, not for the copper sulfate, just for the water. You divide it by 249.5 times by 100, and you should get 36.07%. Question 3 asks, find the percentage composition of copper nitrate. Here's, and if this is easy again, there's no tricks or curveballs, literally just the molecular mass, okay, of your copper nitrate. Break it down, you should get 187.5 grams per mole, and you apply that molecular mass to every element within the compound. You should get for copper 33.87. For your nitrogen, you should get 14.93, and for oxygen, you should get 51.2. So pause this quickly, write down the answers. If you have any questions, drop me a message. There is a special name for our copper sulfate in water, but I'm not going to go into too much of regarding crystallization. That was just a nice way to I wouldn't say trick you guys, but to see if you're paying attention, because it's just asking for water, and we like to do that. So just bear that in mind for the future. You need to read the question carefully, and you need to identify exactly what we're looking for. That's it for this lesson. It's very, very short. The next lesson is going to carry on with the mole ratio and stoichiometry calculations.